Hello, 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 everyone. Hello, are we live? Hello. I don't know if we're live yet. Oh,
We're
yes, we're
live.
live. Hi, I can see me on YouTube now. Hello, and welcome to another exciting anti relativity session on John Chappell Natural Philosophy Society. We've had a few little technical difficulties again. This year now seems to be the time was wrong. It's one of the places I was looking and saying start time is in 12 hours time. So hopefully I haven't lost anybody. But the session is supposed to be now. And let's see if we can put the brand on now saying John uh, Chappell Society needs some money. This can go ahead.
Hello, my name is David Hilser, and I'm president of the John Chappell Natural Philosophy Society. Our organization is unique in the world in that we allow for serious criticisms of mainstream science, from physics to cosmology and from math to philosophy. And today, this organization resides 100% online. If you enjoy our Saturday morning talks, our websites, and the community of amazing critical thinkers you can interact with on the internet, then please consider contributing to our annual fund drive. It costs almost $3,000 per year to keep our internet presence and our Saturday morning talks alive and well. I want to thank all of our members who pay monthly and annual memberships, which is vital to our day-to-day operations. But unfortunately, this is not enough, and that's why we're looking to raise $2,000 in our 2024 drive. So if you don't want this organization to disappear, and you think that its mission is important, then please consider donating to the CNPS. It's vital to keeping science moving forward. Please go to fund.naturalphilosophy.org and donate today. Thanks once again from all of us at the CNPS. Your donation is vital.
Hi, thank you. So I'm back again, and today's session we'll be picking up from last week of Alasdair Beal's paper dealing with Einstein's initial paper in 1905, special relativity. So I shall now try to put the slides up. At the stage. Right. So hopefully you're seeing the slides.
Yes, we can see the slides. You went
Excellent.
on full screen, and
Okay, that's as full as I can get it on this computer. So
well, you might want
that's
to, I don't know, turn on the slideshow feature.
no, that doesn't seem to work. I don't
Start
understand that.
slideshow.
I'm on this laptop and I can't seem to get it to work on there. So I don't know about that. So this is the foot as full as I can make the screen on my laptop.
Okay, well,
So
we can zoom in a little bit more, and you
yeah,
can proceed.
yeah, we can. Can you do that?
Yeah, we can see the slide. It's big enough.
Excellent. Right, excellent. I see. So today's slideshow is about another look at the paper by Alasdair Beal on the errors in Einstein's 1905 special relativity paper. I've been looking at this quite some time now, and I've got a video explaining the mainstream's point of view on Einstein's 1905 special relativity paper and the mathematics that mainstream still seems to deal with is different to the mathematics which Alasdair Beal seemed to be giving us. But I'll be dealing with that next session. On this particular session, I just want to deal with a few, with my understanding of Einstein's 1905 special relativity paper and contrast it to what Alasdair Beal says. So, getting into it, here we go. So, the relevant paper to be discussed is by Alasdair Beal. And something's gone funny there. I'll try again. So the relevant paper to be discussed is this one by Alasdair Beal, and the paper is entitled "Special Relativity and the Lorentz Equations Errors in Einstein's 1905 paper," and it's been published now, I think, in Physics Essays. So Alasdair Beal is criticizing this paper by Einstein, and it's the first paper that Einstein does on special relativity, and it's called "On the Electrodynamics of Moving Bodies," which he published in June 30th, 1905. So what the paper says on the usual translation of that paper is that it was published in German in 1905 in the original, and then it was translated into English. And it was translated into English quite a long time after 1905. And the translation of it appears in this book. It includes papers by Lorentz and Minkowski and Einstein, and the book is called "The Principle of Relativity." And the translation in that book seems to be the authoritative translation of Einstein's 1905 special relativity paper from German into English. Because if you look around, you can find that people have given different translations of Einstein's paper. But it seems to be that this particular translation in this book is the authoritative one. So, going through what Beal says in his introduction, he says Einstein's special theory of relativity was first published in 1905. In this paper, he presented calculations to demonstrate his theory leads to transformation equations for time and distance, matching those previously derived by Lorentz from ether theory. And thus the idea of an ether is superfluous. So Einstein, in his paper, is saying that the ether is superfluous. Most scientists now accept Einstein's theory, and his paper is regarded as one of the most important in physics. So I'm not disagreeing with anything there. That seems to be pretty standard. And then Beal seems to go on to say, in 2007, Hawking stated, the details of Einstein's reasoning and the simple algebra behind are explained nowhere better than is found in Einstein's own words. And the reference Beal gives for that is the Essential Einstein, his greatest works, and that was edited by Stephen Hawking. And then Beal goes on to show that Einstein has made a great many mistakes in his 1905 paper. So it makes you wonder if Hawking ever read that paper, and I think Beal is wondering that as well, because Hawking makes no comment as to there have been any mistakes in Einstein's paper when he's presented it in his book, The Essential Einstein. So Professor Hawking, who has now sadly passed away, has been portrayed as a genius who deals with Einstein's relativity. It would seem very odd if he never read the original paper by Einstein on special relativity. Equally, it would seem very odd if after having read the paper, if he did not comment on the maths mistakes within that paper. So Beal's pointing out maths mistakes, and Hawking doesn't seem to point out any. However, but from the best that I can gather, relativity experts such as Hawking do not in general bother themselves with what they consider historical documents, and instead go by the latest research papers. In the case of special relativity, it has undergone changes from how it was initially presented in 1905. But I think it's a fair analysis to criticise the original paper on relativity, to point out its faults, so long as one is aware that relativity has been changed since then. So Beal has pointed out problems in the original paper, but as far as I think the experts are concerned, like Hawking, that's not relativity anymore. So the scientific method is this. It's about going around in circles all the time. If you look at the top, the first box circle is make observations, and that leads you to the box of think of interesting questions, and that leads you to the next box, formulate hypothesis, and then to the next box, develop testable predictions, and then to the next box after that is gather data to test predictions, and then you have a choice of directions. You either go up to develop general theories, or you go to the right and refine, alter, expand, or reject hypothesis, and then you go back down to develop testable predictions again. So this is sort of a big circle. It's just going around and around in circles all the time, and as you're going around in these circles, what you're doing is making amendments to theory. In particular, in the case of Einstein's special relativity, which he published in 1905, that theory has been subjected to the scientific method where it's been amended. It's been going around and around in circles like this all the time where it's been amended. So the 1905 paper is not really the theory of relativity anymore. Okay. There we go. For myself, I criticise that as moving the goalpost fallacy, where one keeps making amendments to a theory. And in the case of Einstein's relativity, they're making these amendments and they're not making it clear what the amendments are. They're not making a reference to it. So to say, oh, Einstein said such thing, but now in 2024, we don't go by that. Instead, we go by something else. In the relativity lecture, you don't get comment. You don't know what amendments have been made if you're reading a sort of a popular book on relativity, or even a textbook on relativity which is given to physics students. There's just no references to all the amendments that are being made, and so it's a fallacy as far as I'm concerned. But that's the way relativity is. It's just something that's amended, and they're not making it clear what's been amended. But to make amendments to a theory seems to be an accepted part of the scientific method. So in regards to special relativity, it keeps getting amended. So Alasdair Beal criticises an early version of special relativity, but unfortunately it gets amended since then. And what the amendments are not clear if you go in the literature. Anyway, back to Beal's paper. He says, However, there are still some who have raised theoretical objections to Einstein's theory and also questioned its reconciliation with results from experiments and the satellite global positioning system GPS. And the present paper examines the logic and validity of Einstein's analysis and calculations in part one of Einstein's 1905 paper. And some of the people that Beal cites are members of CNPS, and I found that interesting to note that he's going by information from people who are in our group of John Chappell Natural Philosophy Society. Right. Beal says the following: as terms such as x, x prime, y, and t have more than one possible meaning in his calculations, that's Einstein in his calculations, subsets are added in the present paper. So Beal is actually making amendments to the mathematical terminology that Einstein's using. And he's doing that because he says it's for ease of cross-reference. Einstein symbols and general notations are adopted rather than modern notation. Yes, my comment on that is yes, Einstein makes a mess of his maths, starting with making a mess of his mathematical notation. But unfortunately, to some extent, that is goalpost moving again. Einstein's presented his maths with a lot of notation mess, and then we got to move the goalposts and try to tidy that up. Right. Beal goes on to say the following. In his introduction, Einstein states, the view to be developed here will not require an absolutely stationary space provided with special properties. However, in subsequent passages, he refers to the stationary system, the stationary system of coordinates, a stationary rigid rod, the time of the stationary system, stationary space, stationary clocks, and the time of the stationary system. He also compares the timekeeping of travelled clocks, which have moved, with clocks which remained at rest. To understand this, it is necessary to refer to his definition of stationary system, and that in section 1, and he's quoting Einstein for that. Let us take a system of coordinates in which the equations of Newtonian mechanics hold good, in order to render our presentation more precise and to distinguish this system of coordinates verbally from others which will be introduced hereafter. We call it the stationary system. So what Beal says is, thus Einstein's stationary system is not stationary as normally understood. To comply with his definition, it need only be in uniform translatory motion. Also, it's not unique. It could be any of the coordinate systems he introduces in section 2 and 3. And these are all in uniform translatory motion. This should be borne in mind whenever he describes an item as stationary. So my comment on that is, that's all very interesting. In Beal's view, Einstein does not use the word stationary in the way that it's commonly meant. I will come back to that point later. Anyway, back to Beal when he quotes Einstein as saying, let us take a system of coordinates in which the equations of Newtonian mechanics hold good, and so forth. What Einstein actually says is, let us take a system of coordinates in which the equation of mechanics hold good, with a footnote, and the footnote is to the first approximation. And I'm going by that translation, which I consider authoritative. And Beal seems to miss out the footnote to that. So Beal is quoting Einstein saying, let us take a system of coordinates in which the equations of Newtonian mechanics hold good, when it's in the normal standard English translation as saying, let us take a system of coordinates in which the equation of Newtonian mechanics hold good, i.e. to the first approximation. So Beal is missing out that term, i.e. to the first approximation. And with that, i.e. to the first approximation, that comes from what I considered the authoritative translation of Einstein's 1905 paper, which is in this book, The Principle of Relativity. And so Beal's not quoting Einstein in saying that. If we go to what Beal says in his paper, he says he's given acknowledgements, thanks to David Watson for German translation, thanks to Gertrude Walden, and so forth. So he must be going from a different translation than what's been given in the book, The Principle of Relativity. If we go back to the original German paper by Einstein in 1905, it does not have i.e. to the first approximation. It's just something extra that gets added to the English translation in the book, The Principle of Relativity. There is no information provided that Einstein agreed to the i.e. to the first approximation to be added. My mouse is broken. It would be easier to turn these slides over if my mouse is working properly. So I contend that Einstein saying, let us take a system of coordinates in which the equations of Newtonian mechanics are all good. Let's call that Einstein number one. And Einstein saying, let us take a system of coordinates in which the equations of Newtonian mechanics hold good, i.e. to first approximation, let us call Einstein 2. And it's my contention that that's two different theories. Einstein 1 is a different theory to Einstein 2. And part of the problem is, what is Einstein really saying? What is Einstein agreed to? Is Einstein making Einstein 1 statement, or is he making Einstein 2 statement? In Einstein 2, the equation stroke math being stated by Einstein in the 1905 special relativity paper is only approximately true, whereas Einstein 1 and the equation's maths is precise. So it's a difference in the maths. It's just those words gives you different maths. Well, different as to what the math is supposed to mean. Thus, we have the Einstein 1 theory in the original German, and when it's translated into English, it becomes the Einstein 2 theory. This amending of Einstein's theory at a very early stage is, I think, alarming, but amendments are made ever afterwards to Einstein's relativity. So before carrying on, I want to make this point. Einstein's relativity is not a properly defined theory because it keeps getting amended, and we can blame the scientific method for that. Scientific method is just keep amending Einstein's relativity, making a mess of it. So back to Beal, he's saying this. Thus, this is Beal's interpretation from on Einstein's 1905 special relativity paper. He's saying this. Thus, Einstein's stationary system is not stationary as normally understood. To comply with this definition, it need only be in uniform translatory motion. Also, it's not unique. It could be any of the coordinate systems he introduces in section 2 and 3, as these are all in uniform translatory motion. This should be borne in mind whenever he describes an item as stationary. Unfortunately, that's lost me. Is it really not how stationary is normally understood? ? So, unfortunately, what Bill is saying there has confused me a bit. Bill refers to Einstein's 1905 paper and says in section 2 he defines two principles. The first principle is the laws by which the state of physical systems undergo changes are not affected, whether these changes of state be referred to one or the other of two systems of coordinates in uniform translatory motion. And that's called the principle of relativity. And the next principle, number 2, is any ray of light moves in the stationary system of coordinates with a determined velocity c. And c is the speed of light in vacuum, whether the ray be emitted by a stationary or by a moving body. And that's the principle of the constancy of the velocity of light. Well, actually, one of the problems is the word velocity. Did Einstein really mean velocity, or did he mean speed? Because the German word can be translated to either velocity or speed. So there is a bit of confusion there. Beal says, based on Einstein's definition of the stationary system, principle 2 could be more clearly stated as, in a system of coordinates in uniform translatory motion, any ray of light moves with the determined velocity c, the speed of light in vacuum, whether the ray be emitted by a body which is stationary or moving relative to that system. And so my comment on that, so Bill's putting into words what Einstein should have said. Einstein does not use those words, namely of relative to that system, when talking about light speed c or light velocity c. And as far as I'm concerned, that makes what Einstein's saying as ambiguous. And it's also a problem of moving the goalpost again. Einstein says something which seems to be ambiguous, and so you've got to move the goalpost and try to make it more sense. Move the goalpost by changing it into something else to make sense of it. Einstein says, according to Beal, any ray of light moves in the stationary system of coordinates with a determined velocity c, whether the ray be emitted by a stationary or by a moving body. And my extra comment on that is no mention of what that speed c or velocity is relative to. So Beal is trying to amend Einstein to make sense of what Einstein is saying. I don't see that myself. It is moving goalposts. Einstein says something which is ambiguous, and as part of the method of dealing with Einstein, when he says something ambiguous, then somebody would start making amendments to that and try to have him say something else. And I don't see that. I don't see why we're making all these amendments to Einstein's relativity. As we analyse Einstein's paper further, Beal goes on to say such things as, if reciprocity applies to relativistic shortening, logically it should also apply to time dilation, but Einstein does not mention this. Also, there are errors in his calculations. One of the problems that gets pointed out a lot in CMPS is it really time dilation? Is it an effect on time, or is it really just an effect on the clocks? So it's a problem with the terminology again, but anyway, moving on. My comment is Beal is honest in mentioning Einstein does not mention this. There's a lot of things Einstein omits mentioning hence why Einstein is so ambiguous. It all adds up to analysing Einstein's 1905 paper on special relativity, and we find it does not make sense. We've got to make amendments to it to try to make sense of it. So conclusion is taking Alasdair Beal's paper at face value. It makes sense, but it's glossing over the problem. There is a great deal of difficulty in trying to make sense of Einstein's 1905 special relativity. So what Alasdair is presenting is his personal point of view on what Einstein's special relativity is, when actually when we read Einstein's paper, people can make lots of different amendments to what they think Einstein meant. And I think that's pretty much finished the end of my I found what the mainstream thinks about the mathematics of Einstein's relativity in his 1905 paper, and I think it disagrees with what Beal is saying about that mathematics. But that becomes too big a topic, unfortunately. So I'm going to leave it out of this talk and maybe conclude it for the next session of anti-relativity. On this idea of anti-relativity, we all need to disagree what Einstein's relativity is, but unfortunately, Einstein's relativity is ambiguous and people can take it to mean lots of different things. So our starting point of agreeing what Einstein's relativity is before we decide it's the next step is wrong. We can't even agree on Einstein's relativity because it's such a badly written paper. Einstein's paper on relativity is so badly written that you can't even agree what the theory really is. It just gets subjected to numerous amendments by people and they try to make sense of it. So thank you. That's the end of this little talk. And I open the floor now to discussion, possible disagreements and arguments and so forth. Thank you.
All right, Roger. Thank you very much for your
Hey. Okay,
and,
thank you.
and the time it takes to make presentations. I know as an audience, it's easy enough for us to just come here and enjoy what you're saying, but it probably takes a fair amount of presentation and thought to actually be here and present something to us every weekend. So we do appreciate that.
Thank
So
you.
I have been a few questions has come up in my mind.
Yeah.
So one of the points that you did bring up was that you think that the IE first approximation, that significantly changes the theory.
Yes.
Although I don't think that you made a clear distinction as to, how that really changes the theory. My own personal thought was, well, maybe what that could mean to me, and I have this in the comments, that the first approximation would be, for example, if I were to be doing a Newtonian mechanic experiments here on Earth in my bedroom, and to the first approximation, it works out perfectly fine. If I have a little ramp and I roll balls, Newtonian mechanics holds good in my bedroom laboratory. But if you were to do, super sensitive experiments, you would probably find that, that ball is not quite 100% following Newtonian mechanics because the Earth is spinning. And so you might see the ball curving off just a little bit, but it's so small that, it's as to be unmeasurable, right? So that's what I would consider, to the first approximation. And so I think that's fair. So
No, not fair. No, not fair. Einstein's paper Einstein's paper doesn't explain how it's an approximation. So in the translation, it's saying it's an approximation, but doesn't say how. So you've got to add all of this personal interpretation onto it of how is it an approximation, and
Yeah. So once again,
that's not what's in the original German.
but how
In
does
the
that
original
once again
German, it's not an
change anything?
approximation.
How does that
The
change the math? How is that relevant?
Sorry.
How is that relevant? Because I would argue that whether it's the first approximation or not, I don't think that has any impact on, say the twin paradox or any
Well,
of
it
the
does.
other
It
major
messes all that up because you've got some mathematics. Einstein, which I called Einstein 1, the original, I think I called it Einstein 1. The original German, you've got it as not an that math is not an approximation. And then in the translation in the book, The Principle of Relativity, you've got it as an approximation. But you're not, in that book, it's not telling you how that maths is an approximation. So you've omitted all of it. The book has omitted all of that. It's not explaining how it's an approximation. So then you're having to add extra things to it, which is the cycle thing again, going around in circles with the scientific amendment or scientific method, but you got to keep amending theory. So how is it an approximation? People will just go off in different directions trying to explain how it's an approximation. But in the paper itself, it's not explaining that to you. It's just another omission in the theory, which makes the theory ambiguous. Everybody
Well,
can come up with different.
once again,
Everybody can come
my
up with different.
personal opinion there is that an approximation means that those equations that could be off by 0.0001%.
Yeah, it doesn't tell you how much they're off by.
But generally,
It doesn't say how much the equations are off by. It doesn't say how much an approximation it is. It's just the mess.
Once again, if it is just an approximation, but still generally follows the math, then
no, it doesn't. The maths is in the first version. You've got precise maths. There's no approximation, and in the second version, you've got that math is
the
an
same math,
approximation.
right?
Sorry?
You use the same equations.
No, you don't. There's something.
Yes,
If you're
you
doing
do.
an approximation, you've got to show how those equations are an approximation, and that's not being shown to you.
Approximation, it's the same math. I would argue approximation means that it is very, very close.
Yeah, it's close.
That's what it means. It doesn't mean
you could
that you've
you could
adopted
assume
a different. It doesn't mean
you
you've
could assume
adopted
it's
a
close, or you could
different
assume it's
theory.
very different.
No, it doesn't mean you've
people
adopted a different theory, I would say.
with
But
people
I
that
would,
they
I
have
would
tried.
invite other people to join in on the debate because I have my own personal opinion, and that's fine. So,
Well, you could come up with your own version of how to interpret that paper, and people have come up with their own versions
that
of
was
how
one
to
question. Now,
interpret.
the other question
Yeah.
I had, so in your topic, you say that Einstein, that relativity has moved away from the 1905 paper.
Yeah.
And but I didn't see any, I don't know, any authoritative references as to, this is the new relativity
There isn't one.
now accept.
There isn't a paper saying this is the new version of Einstein's relativity. That's another reason why it's so ambiguous. You've got Einstein saying these ambiguous things in 1905, and then people are making amendments to what he's saying in 1905, and they're not saying what these amendments are. They're not precisely documenting what these amendments are, and so they're just leaving it all ambiguous.
Yeah, well,
So
I would
you've
say,
got-
I mean, I know that you harp on like the little translation errors,
Yeah.
but an example that seems to be blazing to me of people just completely rewriting relativity theory is to take the second postulate and say the speed of light is the same as measured in all inertial frames.
Yeah.
This is what they have rewritten relativity into. You ask any mainstream relativist to state the second postulate, and they'll say the speed of light is the same in all inertial frames.
Yeah.
Is how they state it. Now,
Yeah.
Now, exactly what physics book can I look into that boldly says that that's what that says? Because to me, that is the exact opposite of what Einstein is saying. That he's not in any way saying that speed of light is the same.
There are papers that comment that what Einstein understood by the second postulate is not now what we understand by the second postulate, and that's by the mainstream. There are papers like that, but how things change from meaning one thing to meaning something else, that's completely ambiguous. So the people who believe the second postulate means such thing, opposed to people who believe it means something else, it's just complete ambiguity and disagreements. There's
Yeah,
nothing definitive. There's nothing definitive in the literature telling you who's right and who's wrong. There's nothing saying this is the theory of relativity as we now understand it. It's nothing like that. There's just people having different opinions.
Well, that I think we've been in your previous talks, we've been pointing out that Einstein's paper is basically just co-opting Lorentz ether theory
To a certain extent, but I think um, Nicholas Percival goes into a lot of details about that. About Lorentz theory is not really the same as Einstein's theory. So they're both using Lorentz transformations, but Einstein's not putting the same interpretation onto that mathematics. And the mainstream doesn't really want to get into that issue. The mathematics can be interpreted differently. So it's another area of ambiguity.
Well, what was interesting about Alasdair that I was not aware of was Einstein's attempt to rederive, the equations to try it, because the Lorentz theory is obviously based on ether, but Einstein is desperately trying to say that the ether isn't necessary somehow. Yeah. So this all seems to be an effort to discredit ether theory.
Yeah.
But really, his paper is really not saying anything that wasn't already known before, which is, the Lorentz theory, and all the equations he derived pretty much already existed, right? These are all the equations. We had Andrew Castro on, who's a legitimate CERN physicist, and he says, we use relativity all the time.
Yeah.
And it's like, sure, you're using the equations of relativity, which just simply co-opt Lorentz theory, right? And
Andrew is interpreting special relativity his way, and everybody interprets special relativity in different ways. So when he's saying it agrees with experiment, he's placing his interpretation onto special relativity.
Yeah, and then we have other people clarifying that it works if you only use one, say stationary. I mean, I would generally rename that as reference frame, a reference frame, since that's what Alasdair is saying, that it shouldn't be, say, a stationary frame. The only way anything could be stationary is if you declared a preferred physical reference frame, as Einstein says is not necessary. That's the only way you could actually say.
There's loads of problems with
stationary frame, right?
There's loads of problems trying to understand what Einstein says, and when Einstein says ether is superfluous, he doesn't give enough explanation as to what he means by that. And so people read his paper, 1905 paper, and they think, well, he's talking about a stationary system. And when Einstein's talking about a stationary system, that's what people who believe in ether would be calling ether. So Einstein has just done semantics, where he's just using a different word for ether. But
I don't know about that. I guess my personal opinion is that he's saying that, well, instead of having that one preferred fixed physical frame, you can perform the mathematics on any. You can start with any moving frame. So it could be. So it doesn't have to be, because those are two very, very distinct.
It's unfortunately that is the interpretation which a lot of people put onto Einstein's relativity. But when you go into his paper in 1905, there is a lot of ambiguity. When he's dealing with clocks, he does have one clock slower than the other, definitely slower than the other. He doesn't actually use the principle of relativity, so he drops it, and so it sort of that doesn't make sense because I think with people like Nick and that pointed out, if you use the principle of relativity, if you're looking at another person's clock and it's slower than yours, then from the frame of that other person, you should be looking at your clock and saying your clock is slower. But what seems to be happening, the physical thing that seems to be happening is instead that if one clock is slower, then both observers will agree which is the slower clock. But relativity does away with that. The relativity principle properly applied says you don't know which clock is the slower one. Everybody would disagree as to the slower clock. So it is just a mess of confusion. Einstein doesn't explain things properly in his 1905 paper.
Yeah, and well, now you mentioned time dilation. Now,
Yeah,
I mentioned that the Lorentz uh, transformations that had existed prior
yeah,
to Einstein, and I know like say E equals mc squared
yeah,
also existed prior to Einstein,
yeah.
and probably the clock dilation formula probably existed prior to Einstein. I mean, did all these things already exist and were known prior to Einstein?
Well,
Really,
I
all
think Lorentz wasn't. Lorentz was talking about his local time. You had clocks going at different rates, but they're at local time. But I've looked at Einstein more than Lorentz. So you've got Einstein's theory, and it seems to be built on top of what Lorentz was saying. And Lorentz might have been saying things better. But
well, I'm
what
just wondering whether there's actually anything of any original value or difference than what had already been said. I mean, and curiously enough, Einstein's 1905 paper doesn't attribute anything to anybody, which is very unusual. Most scientific papers have a long list of references, but Einstein paper has basically no references.
Yeah, that's
But
right.
that,
Yeah,
that it seems to be co-opting like all of the known things, equals mc squared, Lorentz
yeah,
transformation, time dilation. And so he gets all the credit, but it's probably like in the Lorentz case, he's kind of rederiving things using his own math. Although, like I said, it's just kind of curious that all of
yeah.
these.
It's Einstein's paper is just badly written. He doesn't cite what information he's using, and so if he cited what information he was using, you could then go back to his sources and work out what he's got wrong from that, or if he's right about what he's saying. But you haven't got that with Einstein either. You've got Einstein saying things without uh, clarifying lots of things. Everything is just unclarified.
All right, so we have some people in the green
Okay,
room, and
any
I
people putting their hands up?
we have some comments from James. But if anyone in the green room would like to speak, then go ahead and just wave
Okay,
wildly, and hopefully I'll see you, and then we will put you up. I see that Alasdair is putting
Alistair,
his hand up here, so
put
let's
him
see
up.
what Alasdair has to say about what you've got going on.
Hello,
Welcome
everybody.
back, Alasdair.
Thank you. Um, comments on comments. When I started on all of this thing, I think probably like most people, I spent a lot of time trying to make sense of Einstein's words, because these are the bits that catch your eye, your attention. And yeah, there are all kinds of problems with his words. And specifically, I would rather than lumping them all together, I would like to separate them out. The ones particularly to do with translation, some of them are straightforward translation problems that you get when you're translating between languages. So the one that was mentioned about velocity and speed, that comes from the German word Geschwindigkeit, which can mean either speed or velocity. Speed is a scalar quantity, velocity is a vector quantity. It's a hugely important difference, but in German, one word covers both. The problem in the translation that most people use, I don't agree it's an authoritative translation. It's just one of several translations. It's just the one that's used most often. And the problem in it is the translators decided to always translate Geschwindigkeit as velocity, whereas it's quite clear from the context that in some cases it cannot possibly be velocity, it must be speed. But then there's the issue of the footnotes. Now, there's quite a bit of literature on the added footnotes. And as said, the example given about to the first approximation, that the footnote that's in that English translation isn't in Einstein's original German text. Now, the literature I've read on that says it's not clear who wrote or added the footnotes or what their status is. They were added by the people who were doing the translation, and it's not clear whether they were agreed with Einstein or not. Then you have problems like the one I highlighted in my talk last week, where in the comparison of a third coordinate system and the first coordinate system, there's a phrase of 3 words added in that that's not in Einstein's original German, but it's in that English translation. It's not in other English translations, and it makes a total mess of that bit of Einstein's maths. Now, that class of problem isn't scientists moving the theory on. It's translators grappling with trying to make something written in one language clear in another language. I think all that happened there was that the translators thought Einstein's explanation here is a bit murky, a bit hard to follow. We think we've understood it, so we'll add this phrase so that it brings out the meaning as we understand it, and everybody can see it clearly. The only problem is that they'd misunderstood it and they got it wrong. So they inserted an error, and it's a blatant error. It's not anything else. It's not a change in the theory or development of science. It's just a mistake. And the translators put a mistake in. So you have several classes of problems with the text. And in my early times looking at this, I spent a lot of time on that. I didn't talk about that last week much, or in the paper I've written, because once I started to see that there were errors in his maths, the fact that there was a whole pile of things that we could discuss about his words became rather irrelevant, because his maths is shot through with errors, and it knocks the legs from under the whole thing. There's not really a lot of point in discussing the finer points of the meaning of something when you can see from his maths that what he's done is just plain wrong. The particular things I'd like to draw attention to on the maths side, because this is the important bit. What was Einstein's unique thing he brought to the table? It was, he said he could explain the Lorentz equations by relativity theory, whereas Lorentz had done it from ether theory, and therefore the ether was irrelevant. Now, if you go through the maths and find all the errors in his maths that I've found, that claim falls away. He's failed to show, his maths doesn't show that you can derive the Lorentz equations from relativity theory at all. Once you kick that lot away, well, most of the value of the paper goes with it. And so the classic example of that is time dilation, where he makes a big play of time dilation, and from that, the twins paradox and so on. But he calculated time dilation from the Lorentz equations. Because his maths fails to show that you can derive the Lorentz equations from relativity, that's cut. The link between them is gone. So he's doing time dilation from the Lorentz equations, but all his talk is about relativity theory, and the connection between the two is gone, and that point is proved beyond doubt if you go through his calculation of time dilation and refer it back to the equations that he actually derived from relativity theory. And if you do that, the only conclusion you come to is that T equals 0. His relativity equations don't produce time dilation at all. So the big thing I'm saying is, unless somebody can rescue his maths, the maths collapses. And if the maths collapses, all the words, no matter how clear or murky or difficult, and all the translation errors and everything, all collapse with them. Apart from that, everything's fine.
Okay.
So everything is fine except that it's complete nonsense, is what you're saying, right?
Yes.
I mean, this is like, Andrew's point that, he uses these equations, time dilation, mass increase, E equals mc squared, routinely, they all work.
And that this is the thing with physicists. They all say, when they say they're doing things with special relativity theory, by and large, they're not. What they're doing is they're using the equations that Einstein presented. But those equations are the same as the Lorentz equations. If Andrew's saying, I use these equations, they work, that's fine. But I say, there's not if that's okay, that's okay. The problem is that Einstein failed to show that his theory produces those equations. You can carry on using the equations if you like, but unless somebody can rescue Einstein's theory, you've got to drop it and go and find an alternative explanation for the equations. And Lorentz had an alternative explanation for those equations based on ether theory. In fact, from what I've read people say, it is said in the literature, they're referred to as the Lorentz-Einstein equations by some people. And it's almost impossible to dream up a practical experiment that would distinguish between the two theories, although the two theories are different. So the big point is, if Andrew wants to keep using the Lorentz equations, that's fine. I have no problem with that at all. I do have a problem if he claims that they're based on Einstein's theory, because if he actually reads Einstein's maths in his paper, Einstein's theory doesn't give those equations.
So you have the right answers, but the wrong thinking to get there.
Okay. Can I come in now? Yeah, so the trouble is with Einstein's theory, it does get amended, but it's not clear how it's been amended. And when you're talking about the maths, well, there would have been there is a second part to this session. I omitted doing the maths this time because there's far too much of it to go through. But I'm hoping to do the next session on the maths, where I present what the mainstream views the maths of Einstein's 1905 paper as meaning. They have given their opinion upon what it means. So that's their opinion based on what they now think Einstein's relativity means. So you got this problem of what Einstein says in 1905, and it's not necessarily the same as what people are now believing Einstein's relativity to be. And also, so that is the problem.
But does it really make any difference? I mean, if everyone is just using the equations, Lorentz equations, the time dilation equations, mass increase, and E equals mc squared, then, how does it make any difference? I mean, I think this is why, we never get any traction, because it doesn't make any difference. It's like people, I've tried to read the 1905 paper, and believe me, as soon as I couldn't even get past how the clock synchronization works. as soon as you get past that part of the paper, I believe no human being can actually truly understand what the heck all those squiggles and submarks and
All Greek. They're Greek
all,
letters.
all what that means, And it's like, you're asking of the question of, well, did Stephen Hawking even read this paper?
Yeah.
And I would assert, no, he probably didn't, right? He probably didn't.
I think there's a thing, lots of people have read the paper.
Yeah.
I think very few of them have actually tried to follow the maths in detail, because as presented, it's hard to follow. It looks superficially plausible. They like the sound of the words. The conclusions are the kind of conclusions people want to receive. Therefore, everything's fine. I think Hawking, I'm sure Hawking had read the paper quite a lot of times. I don't think he checked the maths. It's a big claim to make that hardly anybody, certainly among English-speaking physicists, has checked the maths. But what I would claim as proof of, that's a big claim I'm making. What I would say is to prove my claim, the error that I presented, where he has a third system of coordinates, and he claims it's at rest relative to his stationary system. But in fact, if you follow through the English translated text, it's actually moving at 2v relative to his stationary system. And that's the one where that ridiculous piece of maths isn't in Einstein's original paper. It's 3 words that the translators added by mistake.
Yeah.
Now, if English-speaking physicists had actually been checking and following the maths through, they could not have failed to spot that one. It's an absolute howler. So I present that to you as evidence for my proposition that people like the look of his maths, they like the look of his conclusions, but they never checked his maths. And if you check his maths, that you find it's chock full with errors.
Okay, I'm back in. So the elite, the relativity elite, they do say they check the maths of special relativity.
Don't think so.
But they do. They make that claim.
They made a claim. I don't think they have.
They make the claim, but sort of like what I understand from that is they have written many mathematical papers, and what they're doing is looking at the maths of Lorentz transformations.
Correct.
And they're applying group theory to that, and they're applying all the maths to it and say this math is mathematically valid. So they've gone through all the mathematics.
They're saying the Lorentz equations are valid.
And they're saying it's valid. They're not actually
they've not checked Einstein's derivation.
They're not looking at what Einstein is saying.
That's what I'm saying.
Yeah, so
they haven't checked Einstein's maths, and Einstein's maths is full of mistakes.
They're not looking at what Einstein is saying. They're not bothered with what he says about the maths. They just look at the Lorentz transformations.
Correct.
And they say that is a valid piece of mathematics. So they're not bothered with what Einstein says about that maths.
And it was as valid when Lorentz said it as when Einstein said it.
Well, what I've been looking at is mainly is what Einstein says about things, and Einstein says things about his mathematics, and so from what he says, I'm trying to understand what he means by the mathematics. But that's not what the expert elite relativity experts do anymore. They don't bother with what Einstein says about the maths. They just say, we've got this math, the Lorentz transformations. It's mathematically valid. All of it's valid. We apply it to experiments and it works. So what Einstein says is not relevant to those people.
Well, they keep claiming it is, though.
Sorry?
I mean, Hawking, that quotation from Hawking in 2007.
Yeah.
He says...
I queried whether he actually read the paper.
Well, I would say what I'm saying to you...
He just published it. Republished it.
It's what they believe that Einstein's paper does connect and give you the Lorentz equations. They believe that because they've read the paper, but they haven't checked the maths.
Yeah.
Hawking, I'm sure, has read the paper many times, but I'm quite sure that he never checked the maths, or he would have started the problems.
We did think it was relevant because somebody had proven the Lorentz transformations was valid mathematics. So
but
he wouldn't have thought it was relevant then to check what Einstein was saying about that maths.
The relevance is you've got one set of equations, which is the Lorentz equations.
Mm-hmm.
You have two completely different theoretical explanations for them.
What, Lorentz and Einstein?
One is Lorentz's explanation, and the other is Einstein's explanation. Yeah. And scientists have preferred like Einstein's one because it gets them out of the difficulties of ether theory.
Yeah, yeah.
What the
but
problem
if you look at Einstein, he seems to go back to ether theory because he gave a talk in 1920.
But the problem I'm pointing,
so you got
the problem I want to point their noses at is they think that's on the assumption that Einstein's maths is valid.
Mm-hmm.
If Einstein's math is valid, they've got a choice of two possible theories for the equations. However, Einstein's maths is not valid. And when you check it all through properly, it doesn't give the Lorentz equations. So if you want the Lorentz equations, you've got to drop Einstein's explanation for them. You can't have Einstein's explanation anymore because it doesn't do the maths, as the saying goes. You don't get the Lorentz equations from Einstein's explanation.
I'd say his principles are ambiguous, so they get reinterpreted anyway.
Yeah, but there's ambiguity in the words.
Yeah.
There are gross complete errors in the mathematics.
Yeah.
Much clearer than any ambiguity.
Mm-hmm.
Well,
so what Einstein's saying about his math is ambiguous because he's things like the principle of relativity and principle
I'm being picky about this.
It's ambiguous the way he stated it.
I'm being picky about words here.
People, and they have different interpretations of what Einstein meant.
Yeah,
so when he talks about constant light speed, it's different interpretations.
But Roger, what I'm trying to say is the stuff in the maths I've found isn't about ambiguities.
The math
it's about complete gross errors. If you follow his maths through and you try to get to time dilation,
you're diverting
time, please, one at a time.
Yeah, sorry. So what you're doing is diverting onto the mathematics. This session.
No, I'm just pointing out it's important.
No, yeah, it's important mathematics, but that is my plan. Is for the next session is to deal with the mathematics. In this session, I'm dealing with what Einstein's saying, and I'm pointing at this problems and trying to understand what Einstein says. And what Einstein says should really be understood as how he understands what the maths means. And when we got the maths, I've got what the mainstream says about the mathematics in Einstein's 1905 paper. And I think they disagree with what you are saying about the mathematics. So if you're disregarding everything that Einstein says and just looking at the maths, and I think what the mainstream, their understanding of the maths in Einstein's 1905 paper is not in agreement with what you're saying about it.
I've not been able to find anybody.
I found it. I found
there's the points that I've found.
I found it. I've got a video on it. There is. I have done relativity at university and so forth, and I have gone to various different relativity things, and they do concentrate on just teaching you a certain amount of things, and they don't actually go. Most of the time, they don't actually go back to Einstein's 1905 paper because things have moved on since then. They're not really taking that as gospel. No, they're not taking it as gospel when they teach you for relativity. So I've managed to find a relativity course which deals with Einstein's 1905 paper, and it explains to you their understanding of what that mathematics means, and that's probably not the same as what Einstein's understanding of that mathematics back in 1905 would have been, and I think it disagrees with your version of what the mathematics means. So they're quite happy with their interpretation of the mathematics as proving Lorentz transformations and so forth, and they got their own way of looking at it.
Just kind of
that would be a next section.
There's a question in the chat that's come up a couple of times in the chat and it
Yeah.
might be helpful if I just pick it up just now, and then I'll shut up and let somebody else in. John Hodge said wasn't time dilation what didn't Lorentz get length contractions, not time dilation, wasn't time dilation added by special relativity. And another one says, I think I heard that Einstein himself didn't invite time dilation, though I don't know who did. If you go to my paper or the relevant bit of my talk last week, Einstein worked out time dilation by attempting to work out the timekeeping of a clock at the origin of a moving coordinate system relative to a stationary coordinate system. To calculate that, he used the Lorentz equation. What I've pointed at, so it was Lorentz's equation that Einstein used to calculate time dilation. In my paper, I show number one, Einstein's own calculations don't give the Lorentz equation. Number two, his own calculations from relativity theory, if you apply them to that question of the timekeeping of that clock, the only answer they give you is t equals 0. So it was Einstein that came up with time dilation, but he came up with it from Lorentz's equation, not from his own equations. His 1905 paper is, to put it politely, a patchwork quilt. He's cobbled it together. So Einstein presented it, but it didn't come from his theory, and it's not compatible with his theory.
Well, Einstein doesn't.
Anyway, that's me.
Einstein doesn't reference his Lorentz theory. He's got his 1905 paper, and he doesn't reference Lorentz theory. So it is sort of like speculation.
Well, no, it's like
if Einstein's getting it from Lorentz theory, then it's speculation.
No, Roger, he calculates it from the Lorentz equation.
Yeah, for the equipment.
From the Lorentz equation.
Yeah.
And he claims that he's worked out the Lorentz equation from relativity. Okay?
Yeah,
what I'm pointing out is, number one, he didn't calculate the Lorentz equation from special relativity. His calculations were full of errors. And secondly, if you try to calculate time dilation from his special relativity calculations, you don't get the time dilation. You only get the time dilation if you use the Lorentz equation. And the link between the Lorentz equation and Einstein's theory is gone.
Yeah, I don't quite, from your last presentation, I'll have to be honest that I really didn't understand how you were saying that you can't calculate the Lorentz theory. It looked like you said that was just one of possible, like 6 possible things.
Yes, it wasn't a unique solution.
It's not that you can't get it, but that it's not something that is unique.
That's right.
And the other thing is that even if you could derive Lorentz equation using whatever theory you happen to have in your head, that doesn't in any way negate the Lorentz theory. I mean, in some ways, people complain about us talking about this stuff just nonsensically, like it's a giant nit, because, as Andrew and other legitimate scientists state that, they use the equations, the final equations in the relativity paper as proven experimentally correct. And therefore, we don't care how you got there, pretty much. And it's a big nit that we are complaining about, things like, ambiguity. And I think between Alasdair and Roger, Roger is always trying to say that there's errors in the translation, someone put this thing in the footnote, and things like that. And Alasdair is saying that, well, no, that it's really not ambiguity. It's just blatantly wrong, is what what seems to be Alasdair's point. So you really don't have to carry about the little nitpicks. And I'm probably kind of in that same category where the things about the German translations, I don't think are making that much of an impact on what's going on. I would say personally, the biggest impact of the 1905 paper that's wrong and that us dissidents should be more harping on is that that there is an ether. I think the 1905 paper is being used as the main basis for denying the existence of an ether. And that seems to be, I say, Einstein's and everyone else's main motivation for accepting these things, because we can then get into this Alice Wonderland situation where it's like we're basing our entire physics on this notion that there's no ether. But if there is an ether, which is confirmed by, say, the Lorentz transformations, then we're just heading down a completely wrong path for the past 100 years, right?
Yeah.
That would be the biggest deal, right? So for us to complain about that, like there being errors in the translation or there being problems in the math, no wonder why mainstream's ignoring us, right? But that's not the main problem.
Mate,
The main problem is that they're denying an ether. It's their escape. It's their way out, right?
mainstream ignoring it because it's too big a problem. The mess which Einstein has made when he's talking about his theory, and the mess that's been made in the mathematics, they just want to ignore it. It's just too complicated to go into it all.
Now, we also have a lot of comments from James. So James has been commenting in our private green room chat. And so I'm going to bring up James here. But James, just as a hint, what I do is I bring up a YouTube window, because people don't get to see your comments. And we would like to see your comments in the YouTube. So what I normally do is I also open up another window on YouTube. And I think, maybe Roger's already doing that. So we can just monitor all of the conversations. So if you want to be as part of the main conversation that's going on in the main chat, then I would suggest you just open up a YouTube view and put your comments there. But I'm going to bring you up, and we're going to go and have you join the conversation. So here, welcome, James. So I'm seeing your comments.
Hi,
here.
everybody.
I'm seeing your
okay.
comments.
Basically, I have a number of questions which can be addressed to anyone here. Is there anything at all that special relativity theorists say that has scientific merit? Question one. Anything at all?
Well, sure. Like I said, all time dilation, transformation, E equals mc squared, all of that is perfectly valid. Proven experimentally, 100%, no doubt that all the conclusions are correct. I would say so.
So E equals mc squared comes from SR.
It comes from Einstein, at this point.
Again, science.
Doesn't
Well,
that come
I guess
from?
I've stumped the panel here.
Sorry,
I've
no, I was
stumped
waiting.
the panel.
Oh, Roger, you're muted.
No,
somehow.
James, I was politely waiting. You said you had 4 questions, and so rather than butting in, I thought I'd let you lay them on the table.
Let's
And
take
if I
them
was
one
one,
at a
and if
time.
you want answers, I'll try.
Yeah, let's take them one at a time. So to the panel, is that has special relativity?
So E equals mc squared comes from special relativity. Yes or no?
Well, I can answer that.
I've
The
stumped
trouble is
the
that
people. I can't
they were
believe
talking
it.
about that equation before special relativity. So you then got ambiguity
So
as
the
to
question
whether you want to
is
take it from Newton or take it from Einstein.
Thank you, Roger. So in other words, it's not uniquely from SR. Yes,
Correct.
Alasdair, please.
But the common belief is that E equals mc squared comes from relativity, and it doesn't come from Newton. But when you look into it, Newton theory was dealing with it as well. But there was various people who were coming up with similar equations to it. So you've got a problem with what is commonly believed.
Thank you.
As opposed to what's really in the literature.
On that?
Sorry?
My comment on it.
Any more comments on my first question? Alasdair, please.
I'm just about to try to. I've only studied the kinematical part of Einstein's paper. I haven't studied the electrodynamical part. The second on the and d equals mc squared is an electrodynamical part. However, the electrodynamical part is based on the kinematic part, and the thread that the thing that runs through the questions you're raising, James, I think, is there are equations that are claimed to be special relativity equations, but if you look into their background, the equations existed before special relativity. Other people proposed the same equations based on different theories, and so the question is a bit more subtle. The first is, are the equations valid? But secondly, if they're valid, is Einstein's explanation for them valid, or is somebody else's explanation for the same equation more valid? I was using the example of the Lorentz equations, which are to do with the kinematical part, but the same question would apply in E equals mc squared. So to answer your first question, has special relativity any merit? He's explored an interesting idea. I think that's worthwhile in its own right. Einstein explored an interesting idea. He failed to come up with useful conclusions from it in his kinematical analysis. The equations that people use and find useful were also derived by other people from other theories. And the probability in my mind is that the equations may well be valid, but it's somebody else's explanation for them that applies, not Einstein's.
So is Einstein just a great plagiarist?
Well, I find this very, very useful. In other words, our panel here is more or less seems to agree that things like E equals mc squared are not uniquely from relativity, but can be found in the physics literature of other investigators prior to Einstein's 1905 paper. So my next question, are we ready for my next question?
Okay.
What experiments would clarify each ambiguity mentioned today? What experiments would clarify these ambiguities? Or if there's not much scientific merit in special relativity to begin with, maybe it's not even worth it to do those experiments.
On the kinematical part of special relativity, as that's the first part of the 1905 paper, in my view, there's no point in trying to do experiments because the maths and the logic doesn't hang together. And if the maths is all wrong, then you can, no matter what experiments you do, you can't rescue the theory if the theory is not mathematically coherent. If your theory is wrong,
okay,
doing experiments can't make it right. Okay. You can only test. Experiments are only worth doing to test if a theory that's actually logically and mathematically coherent for starters.
Okay, so I can give my version of the answer. Sorry, my version of the answer is experiments won't clarify the ambiguity because there's an issue called underdetermination, which basically means that experiments can be interpreted by different theories, and physicists seem to ignore that. They just want to believe that experiments can be only interpreted by one theory. But because of the ambiguity, it means that people are interpreting experiments by different theories, and they're then just calling it special relativity.
Now, I would disagree. I would say yes.
Thank you, Roger.
I would say definitely there are experiments that can be done, have been proposed. The twin paradox experiment is an example of that. I mean, even
can't do that one.
Even relativists would agree that there is a problem there. There's a difference where you do an experiment, it is making a specific theoretical prediction, which is that twin A will be older than twin B, and twin B will be simultaneously older than twin A. That is a definite consequence of using the relativity part his 1905 paper. Now, that doesn't have anything to do about, say, the Lorentz equation or the specific time dilation, presuming stationary frame. But if this is the thing that theorists complain about, and it's strange to see that it is recognized by relativists that there is a problem here, that is a direct consequence of relativity theory. But then they go and they do not use ambiguity. What they do is they just go and do provide illogical explanations, such as saying that in those cases, there's some acceleration on the returning twin, therefore you're not an inertial system, therefore none of this applies, that kind of logic. But theoretically, if you could come up with some situation where no return was required, perhaps you're just going in a big circle, so you're under constant acceleration in both directions, and any effects should cancel each other out, so that you don't have this return whatever. I mean, I'm sure there are ways of doing it, but quite clearly experiments, things like the Haffey-Keating experiment, which is specifically designed to try and tease this whole question out, show that no, that contrary to Einstein's assertion that no absolute stationary frame is required, that is clearly experimentally been shown wrong, right? And by those kinds of experiments, and GPS also shows that a preferred frame is absolutely required. In the case of GPS, we have found that to be the Earth-centered inertial frame. So experimentally, yes, we can run experiments that can give a thumbs up or thumbs down to the theory, and quite clearly, giant thumbs down for Einstein's assertions that no preferred frame is necessary. That would be my explanation. So I don't go away by trying to provide explanations by saying, "Oh, the math is wrong, so you can't do experiments." Or that this can be interpreted in other ways. I would do a solid. Yes, experiments can be done, and experiments have proven that special relativity doesn't make any sense at all. That's would be
so. My comment on that is, if you get the twin paradox, you can't really do a proper experiment on that. It's just more of a theoretical thing. And when you got onto GPS, it was our expert on that, who sadly passed away, Ron Hatch. He was the expert on that, and he was claiming it wasn't obeying Einstein's relativity, that you didn't need it. But the problem with Einstein's relativity, if you apply it to GPS, you've got some people who believe that Einstein's relativity has a preferred frame, and some people who believe Einstein's relativity doesn't have a preferred frame. So you've got a difference in interpretation of Einstein's relativity. So once again, you've got a difference in how GPS is being interpreted. You can interpret experiments such as GPS by different theories. And that's called underdetermination.
Okay,
and that's not readily accepted by experimental physicists. They kind of like to believe that experiments can only be interpreted by one theory. But what you've got with Einstein's relativity is ambiguity as to what exactly Einstein's relativity is.
Okay, prior to my last question, let me just say that Franklin brought me up so fast, I didn't have time to open the window to bring some light onto this side. So I'm halfway in the dark here. My last question, which anybody here might want to address, is what new different assumptions might help create a better theory?
For me, I think the assumption should be that there is an ether, that there is a physical preferred frame. That would greatly help make a better theory. Once you set that up, then you have a rock solid foundation upon which you can build a physics that we say observe in GPS.
Yeah, okay, ether.
Yes,
Bring back the ether.
I'm not pushing a line on it.
Oh.
I'm not pushing a line on any particular theory. The work I've done has purely been to look at the validity of Einstein's theory and the claim that it produces the Lorentz equations. And having found that the maths is full of errors, the Lorentz equations are one of 4 possible solutions to Einstein's calculations. The conclusion I take from that is, if you want to hold on to Einstein's theory, then you have to ditch the Lorentz equations. If you want to hold on to the Lorentz equations, you've got to ditch Einstein's theory. The question of what theory you want to use to replace is, having opened the door for you clever guys, I'll leave you to work that one out. I'm quite happy to just throw the question open for proper scientific investigation.
But excellent questions, James.
Well, thank you, Roger and Alasdair and Franklin. Now, I'll open my window now, so I get more and more light in. Bye-bye.
I think you still had
Dennis
some other
has some nice comments.
Is like, what is it here? So yeah, you were wondering who reviewed the 1905 paper. I mean, during that time, did they have even such a strict peer review system at all? I mean, I was recently reading this article of what happened if Einstein was here today and tried to publish such a paper, and the conclusion was that he would never ever be able to get that published. It would not be
exactly.
Yeah,
exactly.
Yeah. I think when I've looked into that, I think Einstein was only peer reviewed once, and then he failed peer review, and he seemed to be exempt from being peer reviewed. So his 1905 papers seemed to be published because he was friends with the person who ran the journal, who was one of the main people running that journal. He was Max Planck. He was friends with Max Planck.
Very interesting.
Max Planck allowed it to be published, but sort of his papers, Einstein's papers, didn't have any references to say what he'd been working for, and ideally,
a gigantic job, plagiarism job.
Sorry.
That's what you do when you have a plagiarism job. You don't attribute your ideas to anybody. You just
ideally a paper without any references should be rejected. But Einstein, because of his friend with Max Planck allowed that to be published. So that is part of the mess already. Which wouldn't matter too much because Einstein wasn't become famous where people started taking more interest in what he was saying until 1919. If he then sort of like explained where his ideas were coming from, gave references, then we could have picked up what he was talking about from earlier sources. But he didn't seem to do that either. So Einstein just left his sources unreferenced.
There was a question I noticed in the chat addressed to me about the problem being the principle of the constancy of the speed of light. If that, to my view, to my mind, is an empirical fact. Either it is or isn't constant, and I'm not going to fight facts ever. The bit that is interest to me and where I've followed the route on the mathematics of Einstein's calculations is he proposed that the speed of light was constant relative to what he called the stationary frame, which, according to his definition, could be any frame in uniform translatory motion. And if you try to, I think he found out, if you try to do the calculations if the speed of light is constant relative to one frame, and it's also constant relative to another frame and the two frames are moving relative to one another, you very quickly end up in some massive tangles in your mathematics. And he tried to cut a way through that, but as I've set out in my paper, I won't labor it today because I set it out last week. Yeah. He monumentally failed in that.
Yeah.
Now I don't blame him for that. It's extraordinarily difficult. I couldn't see when I'd spotted the errors in his maths, people said to me, well, what happens if you correct them? I couldn't see how to correct them. There was the problems are just too difficult.
Yeah, that's why I started looking at what Einstein was saying, because I couldn't see how to correct the mathematics, and so I wanted to concentrate on what he was saying, and so what he meant, and then from what he meant, you could say what maths he was really talking about. But you got ambiguity in the math and in the what he says, and ambiguity because he's not referencing his sources. So it's just a total mess. It's not. There's nothing you can grab onto and say definitely what's going on. All you got is possible vague interpretations, which you can impose upon it.
Well, I mean, if we presume that the conclusions are correct, but the method was wrong, then maybe it's just kind of a symptom that people read it differently, because if it's nonsense, then only nonsense can be used to explain it, right? Now, if it was actually correct in nature, it would be much more difficult to do that. But like if I come up with a theory that says the moon is made out of cheese, and then you try and interpret that in different ways. Well, maybe it's made out of cow milk, or maybe it's made out of goat's milk. No, it's not that's not that. It's just that it's not cheese at all is what the problem is, right? Because it's nonsense, right?
You could redefine what cheese was, because
Yeah,
when you go with Einstein,
cheese is made out of a dust-like particle.
yeah, you could
Like
redefine.
that's my cheese.
That's another problem with Einstein. He redefines terms, because from Newton's theory, you would say that time is absolute, but Einstein seems to want time is relative, and he wants space and time to be flexible, and he got space-time curvature. So he's adding all these changes to what were the original definitions for these terms. So that's how that adds another layer of confusion. So if you say the moon's made out of cheese, somebody goes there and finds it's made out of dust. The next step Einstein would do is say, well, yeah, that's what cheese is made out of, dust.
Yes, and I think that these kinds of things, I'm just pointing out that if you have a nonsense theory, it's very easy to just wiggle your way around it. But if I say the cheese is made out of moon regolith, it's made out of these specific elements that we've measured on our instruments, then it's very difficult for someone to say, no, let me go and change it so that magnesium is now cheese, because people can immediately recognize that's wrong, right? But if you're starting with the assumption that the moon is made of cheese, or that relativity theory, all that mathematic works, right? Then you can say anything you want.
There are different types. There are different types of cheese, so you could say that magnesium was a different type of cheese to what we're commonly.
Yeah, go ahead, Alasdair.
I noticed another question in the chat, which was, why was I not able to correct the mistakes in Einstein's maths? That was a question I asked myself when I found the first mistake.
Yeah.
But once I was about 10 levels in to multiple mistakes and changes in assumptions, there is anybody has experience of troubleshooting a mathematical or engineering problem knows that if there's one or two things wrong, it can be possible to correct them and fix it and make it right. But the more mistakes, the more errors there are, you come to a point where only a complete rewrite will fix it.
Yeah.
And I looked at the thing and I tried and I failed. Maybe my brain's not big enough. I'm quite happy to bear with me, please, Roger.
I agree with that. Yeah.
The questioner says, why couldn't I do it? Maybe my brain's not big enough. I would say, have a look at the mistakes that I've listed in the talk last week and in the paper. Take a bit of time to understand them all, and then over to you. If you can come up with a way of fixing them all and getting satisfactory answers, I'd be very interested. I looked at it and it was beyond me.
Okay, well, we've got Stephen Gift, who's been waiting anxiously.
Yeah.
So, Stephen, what do you think of all this?
Well, thank you very much, and good morning, everyone. Alasdair, I heard your presentation last week, and I listened to some of what you said today. I wasn't here for the whole thing, but I wanted to make a few comments. I think your position is that you're referring to special relativity, I presume, as the two postulates separate from the Lorentz transformations. The world in physics, as it is in physics today, that separation is not how it's viewed. Special relativity comprises the two postulates which lead to the Lorentz transformations. So that's the first point I wish to make. And I mean, it's not good to come up with new conventions and which you may just confuse the situation. But let's say you wish to separate them. Your main point is that there are these mistakes in Einstein's paper. Well, it seems that you have not looked beyond. The paper was written in 1905. There are hundreds of papers and many books written since. And I could suggest to you French's book on relativity, Rindler's book on relativity, Resnick's book on relativity, where you will find correct derivations of the Lorentz transformations from the two postulates. Good. So to argue that because the 1905 paper has errors and therefore the transformations are wrong, at the time, if you made that argument, I guess it would have been fine. But a lot of work has been done since that time. And you can find what I believe are correct derivations of the Lorentz transformations from the two postulates. The two postulates being the relativity postulate and the principle of light speed invariance postulate. So that is a major point I wish to make to you. Now, my position is that I have tested Roger, just let me make these points. Yeah.
Okay.
Yeah, I have examined the whole theory, as Roger knows and Franklin knows, and I have found the Lorentz transformations to be wrong. And here are a few reasons why I consider them wrong. One is those two postulates, particularly the light speed invariance postulate, I have shown using the GPS that is incorrect, that it is not true, and therefore the theory must be wrong. That's one. And then I've gone on to use the Lorentz transformations to see the predictions it has made. And I have examined several of them. Many of them are correct, by the way. So for instance, transverse Doppler predicted by the Lorentz transformations, that has been found to be correct. Relativistic beaming has been predicted by the Lorentz transformations and found to be correct. Thomas precession has been predicted by the Lorentz transformation and found to be correct. But some other predictions that it has made that are wrong include, for instance, it predicts constant light speed. After all, it is based on constant light speed. So it makes that prediction. And as a result, it fails the Michelson-Gale experiment because it predicts constant light speed, and therefore the fringe shifts are all zero in that experiment, when in fact the fringe shifts are not zero. And there are several other examples of where it has made invalid predictions. So in closing, Alasdair, the theory is wrong, and when I say theory, I mean the postulates leading to the Lorentz transformation. That is what is seen as special relativity today. It is wrong because at least one of the postulates is wrong. That is, light speed invariance is not correct. And then several of its predictions are also found to be wrong. And finally, you asked for, well, what can we do to replace? What replacement is there? I have introduced in my presentation to this group several weeks ago there are transformations which are referred to as the celery transformations. You may not be familiar with them, Alasdair, because you have confined yourself to this narrow area in Einstein's paper. But there are transformations called the celery transformations, which I have tested exhaustively. I have gone through all of the material in those relativity textbooks, and I have shown with complete sets of analysis, which I've shared with Roger and Franklin and the whole group, email group, to show that the celery transformation makes, as far as I'm aware, it passes all the tests to which I have subjected it, and I stand ready to defend it until somebody shows it to be invalid. And I'm trying my best to promote that theory now.
Yeah.
Yes, yes.
Okay, thank you, Stephen. Thank you.
Stefan, yes.
Today's talk was about Einstein's 1905 special relativity paper, and what is being taught is not exactly the same as what's in that paper, and we were trying to make sense of what that paper was talking about. So going on to what the mainstream is now saying is relativity is another issue. It was not the issue.
I thought it was, Roger, I thought it was related because
Sorry?
Alasdair is making some points, and I was countering those points with the comments that I made. I think what I said was very relevant.
So what we were dealing with was with Einstein's original paper on relativity, and we were trying to make sense of it, and we had problems with that. If you go on further, then I have read papers which talk about deal with the mathematics of the Lorentz transformation and say that is valid mathematically. That is a valid piece of mathematics. So unfortunately, you want to go on to then talk about Sorelli transformations, and in the context of what those other papers are talking about, it's then difficult to understand what you're meaning, because relativity has changed since 1905.
Yeah. But I was responding to what Alasdair said and the conclusions he was drawing. All the comments I have made follow from what he has said. Right.
Okay.
Please. He wants to make a comment though, Rogers. Yeah. Yes, Alasdair.
Hello, Stefan. Firstly, I did watch your talk about the celery transformation. I thought it was very good and very interesting.
Yes, thank you.
Secondly, the deliberately narrow focus to what I've done. It's purely about Einstein. It's not about the whole of relativity theory, all the versions of that might exist, and all their validity in every respect. That's way beyond me. I've spent my time looking specifically and narrowly at the 1905 paper in its own right, because it gets talked about so much. It set off some of the ideas that have debates that have kept people going for decades. I thought, look at its merits in its own right. And so I was surprised, but there it is, when I found that the maths was all wrong in it. That doesn't prove that there are no... I don't have a view as to whether special relativity can be rescued or not. I couldn't see a way around the mathematical problems in Einstein's paper. What I would say is, if there are other versions, I'm trying to throw the door open a bit to people. Einstein's papers hogged the limelight for so long, and it doesn't deserve it. I'm saying Einstein's paper, not the equations that scientists, physicists use, but Einstein's explanation for them needs to be dropped. If there are other explanations that sort things out, whether with Lorentz equations or the Celery ones, that's fine. But then we need to drop Einstein's 1905 paper from the discussion and say, come on, where is the explanation that can replace it? Because Einstein's 1905 explanation doesn't work. That's my personal position.
Yes, and if I may, Alasdair, I agree with you that it probably doesn't work. I've looked at it, and I haven't spent a whole lot of time on it. But you see, you are drawing the conclusion that because the 1905 mathematics is wrong, it means therefore that we can't now rely on the Lorentz transformations.
No, I'm not saying that at all.
No, you said that in your last presentation.
No, I
You
didn't.
said many times, you were telling us that even today you were suggesting, when in response to a question about going to look at some experiments, you didn't even want to entertain that because you felt that if the mathematics is wrong, then it means that the what has been produced by the mathematics isn't what worthy of being tested. And that's why
I've obviously not explained my thoughts clearly enough, and I apologize for that if that's my fault. I'm not saying the Lorentz equations are wrong. What I'm saying is the Lorentz equations exist. Einstein's 1905 paper, his big claim was that he could derive equations identical to Lorentz from his theory. And what I'm saying is wrong is that claim of Einstein's is wrong. The mathematical calculation to link his theory to the Lorentz equations doesn't work. It fails. Too many mistakes. You're therefore left with a situation, as in life, there are always three options. The first option is take the postulates of special relativity, do a completely new mathematical analysis that picks up and corrects all of Einstein's mistakes. And as good luck has it, having corrected all the mistakes, you come up with the same answers. If you can do that one, everything's fine.
And my contention is that it has been done.
If I was a gambling man, I wouldn't put a lot of money on that one.
Yeah, Alasdair.
The second and third options are, unless you can do that, you have to say, I'm holding on to Einstein's theory, but I'm going to do correct calculations, and I'm going to have to dump the Lorentz equations. That's option 2. And option 3 is, I'm going to hold on to the Lorentz equations because they work. And if Einstein's math doesn't work, I'm going to dump Einstein's theory. I'm not saying which people should do. I'm only pointing out logically, those are the options. And the one that you can't hold on to is on the basis that Einstein's 1905 paper proves that his theory gives the Lorentz equations, because it doesn't.
Yes, and as I'm saying, the correction, if you want to call it that, has been done. That's the point I'm trying to make.
That would be in place to Einstein's paper then.
Yeah. Whether or not you want to call it a correction, or they have simply come up with new mathematics to move from the two postulates to the Lorentz transformations, I'm saying that is available. So that point you are making about, well, the mathematics is wrong, so you have these options, they have corrected the mathematics. And I mentioned several texts, and it's all there. And
would you agree that you would have to replace Einstein's paper with them?
No.
Einstein's paper's wrong. These are the correct.
Well, I am saying the world of physics has done that, even though, and they're doing what Roger says, they treat the 1905 paper as historical. But nobody goes back there to look to see, to use that material. The textbooks may refer to it for its historical content. But today, the physics textbooks, I was looking at one this morning, published in 2016, a very well-written book. 1905 paper is mentioned in the appendix somewhere. But they have the mathematics that has been corrected over 100 years to show how you go from the postulates to the Lorentz transformations.
Okay,
so
we're towards the end here.
2007, Hawking said that Einstein's was still the best explanation.
Well, Hawking's was wrong. Hawking's
I
was
agree
wrong.
with you.
And but the physics book. So we have to just be clear that that material is available. And I think, Alasdair, because you confined yourself to that paper and didn't seem to look beyond to see what has happened since, you may have missed the fact that the correction has been made. But they promote Einstein as a genius, so they don't talk about his paper having errors. But that doesn't mean we must just follow along with that proposition.
But Stefan, give me a chance.
Sure.
If I've been ignorant and missed the fact that physicists know that Einstein's paper is wrong and there's a better replacement available, I'm in quite good company because Stephen Hawking's missed it as well.
Well, I don't want to.
Stephen, can you put in the comments like a specific reference, preferably a hyperlink, so that Alasdair and the rest of us can go ahead and take a look at that, because that's very interesting.
That'd be very useful.
Your point is well made, but we are getting towards the end of the talk here. Okay. So I would like to thank everybody for
thanks for letting me in
and making it. I always like a heated, passionate debate going on here. So I appreciate that. Make everything exciting for everyone else. But we do have 5 minutes. I don't know whether there anyone else like Dennis or Vladimir wanted to say anything. Vladimir, did you want to say something? Okay, I'm going to put up Vladimir for a second. Okay, Vladimir, what do you think is going on here?
Let me tell me my opinion. I absolutely agree with you, Franklin, about the special relativity. It is not the translation issue. It is not a theoretical issue, mathematical issue. The main issue is, there is an ether or not? There is a speed of light in or not? Unfortunately, abandoning the luminiferous ether in 1905 by special relativity was crucial for classical physics. The medium exists. There are some experimental proofs for existence of the medium. There is no velocity of speed in vacuum, speed of light in vacuum as a constant. It's not a constant. That's why we should stop these, talks about the special relativity, because even basic postulates of them is wrong. That's why what I want to tell you, that next time in my presentation, I will talk about the medium of the world. I will talk about what is going on with the real life, with the real world. That's why all these mathematical, logical, and all these issues, they are wrong. We need to pass over them and to start a new life with the real world and with the real experimental results. You are very welcome to visit the next seminar. I will present my first presentation, The Medium of the World, and I will try to convince you that we should start thinking in a new way, in a real life, in a real world, what we live in. Thank you so much.
All right. Okay. Well, that's great. I mean, I would think that, for example, if, say, the University of Washington, some physicists announced actually, say, finding the ether, like I postulated being a positron, electron, C, and, that's something that could be experimentally found, right? So if that could be proven, then, obviously at that point, then all of this relativity stuff would fall away. There's no way that the experimental establishment of an ether, special relativity, could survive in that. It would just be dead on arrival. But, like you said, like Vladimir saying that if we could get to that point, I think maybe we'd be making some progress rather than us, I don't know, we're seemingly talking about nits. But we're at the end here, so I'm going to give Roger the last say here, and it looks like you're muted, Roger. So make sure to unmute yourself there.
Hi, thank you. Right, so this session was on Einstein's 1905 special relativity, and pointed out some of the problems with trying to understand what the paper was saying. Next session will hopefully be upon the mathematics, and the issue just gets worse. Trying to make sense of the mathematics is even worse than what we've dealt with this time. So put on your mathematical heads for the next session, which should be in 2 weeks' time, or hopefully. Thank you.
Right, thank you. That will do it for this episode of the NPS chat.
Okay.